Hello everyone, my name is Min Pham and today I'll be presenting my final project on forecasting NVIDIA stock prices using ARIMA model. Now as a NVIDIA stock investor, I promise this isn't financial advice. I was genuinely excited to apply what we have learned in this course. In this project, I explore different ARIMA models to answer a simple but important question. What is the more accurate model to forecast NVIDIA adjusted closing price over the next 10 days? To begin the analysis, I explore the overall structure of NVIDIA prices from 2022 to 2024. As shown in the top pillar, there is a strong upward trend, especially from early 2023 to early 2024. However, the more recent data show a local downturn, which is important context for our daily short-term forecasting. The XTL decomposition also confirmed this, revealing mild seasonal pattern, but the trend component clearly dominates. We also see changing variance. Price swings become more extreme after mid-2023. The behavior of this series appears non-linear, almost exponential at times, suggesting spectacular growth. And finally, a clear change point occurred around mid-2023, where both the slope and variance shift. Next, the histogram shows that the close prices are heavily right-skewed, indicating non-normality. The ECF plot confirms strong autocorrelation and non-stationary. Therefore, I apply a post-cost transformation to stabilize variance and then difference the series. Now, as seen in the final plot, the transform and difference series is now stationary, which is a key requirement for reliable ARIMA modeling. To determine the appropriate ARIMA model, I began by analyzing the ACF and PACF of the first difference transform series. Now both plots show no significant spikes. Beyond that, a simple ARIMA 010 is recommended. The ACF also suggested ARIMA 010 and suggested ARIMA 111 or ARIMA 011 as regional model, while the BAC heat map pointed to more complex options like ARIMA 313 and ARIMA 315. I listed all the candidate models on the right, which I will evaluate them in the detail for the next slide. The table compares our candidates model. ARIMA 315 had the lowest MSE, MAE, and MPE, and its ACF1 is close to 0, showing strong predictive accuracy. Other ARIMA 313 had the lowest AIC and BIC, its high error metric and ACF1 disqualified. Simpler models like ARIMA 011 and ARIMA 111 perform acceptably but lack significance. For overall, I choose ARIMA 315 because it provides the best balance. Now, let's do the residual analysis check for ARIMA 315. They fluctuate randomly around 0, suggesting stationary. The histogram is bell-shaped, but the QQ plot and Shapiro-Wills test show non-normality in the tails. ACF and Boston test confirm no significant autocorrelation, so while residuals aren't perfectly normal, they are uncorrelated and centered, suitable for forecasting. To wrap up, here the 10-day forecast generated by the ARIMA 315 model. As you can see from the point forecast value and the chart above, the model predicts a stable to slightly declining trend. The prediction interval widened over time, which is expected and reflect growing uncertainty. Overall, ARIMA 315 proved to be the most accurate model, balancing low forecast error and well-behaved residual, even though not all coefficients were statistically significant. Thank you for your attention.